Dear students, good afternoon. And previously we discussed about discovery of electron, and now we will discuss about discovery of proton. And proton was discovered by Goldstein. Okay, so Goldstein discovered a proton. Actually, it's very simple if you understand discovery of electron. How electron was discovered? By using cathode ray discharge tube experiment. Same story. So by using the same cathode ray discharge tube experiment, he also was discovered proton, but he was sent current in opposite direction. Actually, in discovery of electron, the current flow from cathode to anode. So rays traveled from cathode to anode happened actually. So he did ulta, means reverse. Means what he did, he sent current from anode to cathode, and he kept that zinc sulfide screen behind cathode actually. Get it? Then he observed opposite to the cathode rays, some positive rays was traveled from anode to cathode. That was observed by whom? Mr. Goldstein. So what I was given here, I'll write. So here it's a discharge tube. So actually in discovery of electron, you have a cathode here, you have anode, and cathode means it's minus and anode means plus, like this, correct? So cathode rays means travels from cathode to anode in a straight line. So they move straightly. So I told no that one. So in presence of some electric field, they will deflect. In presence of magnetic field, they will deflect, unless they move straightly actually. So here same story, here you have a battery as well as high voltage battery around 10,000 volts we will send 10,000, okay, 10,000 volt battery, and here you have a switch, okay, like this. Now he sent in this direction and the screen was here, screen kept here. Here you have a screen. What screen that is called? Zinc sulfide screen or fluorescent screen or phosphorescent screen. Okay, fluorescent or phosphorescent screen. So here this is screen. What screen that is? Zinc sulfide screen this is. Got it clearly? So what he observed, some rays are traveling from anode to cathode actually now. So previously what I said, cathode to anode, some negative rays was traveled, they are invisible, but once they hit the screen, they glow brightly. Means they will give a flash, like when you take photo, you will get one flash, no, in that way you will get flash when those rays hits that screen. So very simple thing, cathode rays are traveling from cathode to anode, but anode rays are traveling opposite direction to the cathode rays. That means from anode to cathode they are traveling. Okay, so in this direction you have like this, but direction is in this way. So right to left. So this is actually anode and this is cathode actually. Okay, so these rays actually called what rays, you know? Anode rays. What rays they are called? Anode rays, which are traveling from anode to cathode, and they also called canal rays. Canal means positive. Got it clearly? So very simple thing. So cathode rays are traveling from cathode to anode. Cathode rays are negative rays, but anode rays are traveling from anode to cathode. So very simple thing. He just copied. Goldstein was copied the experiment which was done by J.J. Thomson. So J.J. Thomson observed the rays are traveling from cathode to anode like this, but he observed, he means Goldstein observed, the rays are traveling opposite to the cathode rays from anode to cathode like that. Got it clearly? So this was this experiment was given by Goldstein, and cathode rays are traveling from cathode to anode, but anode rays are traveling from, what's that? Traveling from anode to Anode to cathode actually. So these anode rays are positive or negative? Anode rays are positive rays. So anode rays consist of what? Anode rays consist of anode rays consist of, do you know what? Anode rays consist of protons. Anode rays consist of what, sir? Protons. And one more thing, anode rays do not depend on nature of gas what we take. And here we are taking no gas. Gas is unnecessary because anode rays are positive and they are highly somewhat heavy particles. This. So whatever the gas is, they won't affect because protons are ejecting from the center. So every nucleus of gas consists of same mass because protons are same. Okay, so they won't affect, that means nature of gas won't affect the particular anode rays. So one more thing is that anode rays are independent. What is that? Anode rays are independent on nature of gas. These are very important points. So anode rays are independent on nature of gas. So these all are very important for you. Okay. So anode rays, as I told, anode rays consist of protons now. Cathode rays consist of electrons. Is it clear now? Okay. So anode rays and cathode rays, one more important thing. So this cathode rays consist of what, sir? Electrons. And electron has charge to mass ratio. Charge to mass ratio that was given by the deflection which was happened due to presence of external electric field or magnetic field. Okay, that was given like this. Charge to mass ratio of electron means, you know, that ratio is called E by M ratio. What ratio that is called? E by M ratio. So E by M means, E means charge, M means mass. E by M of electron is nothing but minus 1.602 into 10 power minus 19 coulombs by, what I need understood? Electron charge. What is electron charge? Minus 1.602 into 10 power minus 19 coulombs by 9.1 into 10 power minus 31. Okay, so if you do this, you will get it's minus 1.17 something into 10 power plus 11, because 10 power minus 31 goes to numerator, it will be plus 31. Okay, minus 31 become plus 31. Okay, so it is coulomb per kg. Very important. Charge to mass ratio of electron means like this. Same charge to mass ratio of proton, you can say now. Okay, so what is E by M of proton? So what is the proton mass charge I was given? 1 point, same only, but plus 1.602 into 10 power minus 19 by this 1.67 into 10 power minus 27. This is coulomb and this is kg. Am I given this? Coulombs and mass of proton I was given or not? So E by M value is very important. How they was given is unnecessary for you. That is beyond our syllabus. Okay, just how the charge of electron we have and what is the mass of electron and E by M ratio is what. That's it. And we have concepts more deeply about electron actually. Bohr's model, hydrogen spectrum, like that, quantum numbers, not this. This is just information I am giving. Okay, so E by M of proton is 1.602 into 10 power minus 19 by 1.67 into 10 power minus 27. It is actually by after simplification it is 9.57 into 58 or something 10 power 7 coulomb per kg. Coulomb per kg. So this is about proton discovery and protons how discovered from cathode ray discharge tube experiment or anode ray discharge tube experiment. Anode ray discharge tube experiment. Anode rays are traveling from anode to cathode. Got it? And one more important thing is these anode rays are independent on nature of gas. Anode rays are also moving straightly. Okay? And one more thing, anode rays will deflect for external electric field? Yes. But anode rays are deflecting towards external cathode. Getting what I am saying? What I said about cathode rays will deflect towards external anode, like this I was given. I think that way. Correct? Actually cathode ray moves straightly, but cathode rays are deflecting towards external anode I was given. But anode rays, everything ulta. Anode rays also will deflect in presence of external electric field as well as external magnetic field. So what I am trying to tell you is, so I will give here. So here you have external anode rays are traveling from, this is plus and this is minus. So anode rays are traveling from anode to cathode. Actually this is external field, this is plus external anode, and this is minus external cathode. So what happens if this external anode and external cathode is not there? They move straightly, correct? But these will deflect towards external cathode, deflecting towards external cathode. This is original cathode which was fit to a particular discharge tube, and this is externally we kept. Before this cathode we kept this external cathode and external anode like that, and suddenly what happens, these anode rays deflecting towards external cathode, because anode rays are positive, so positive deflecting towards negative. Same if you use magnetic field, same thing will happen. If you use magnetic field, what happens? The deflection of anode rays towards north pole. Write down all these things. Anode rays will deflect in presence of external electric field and magnetic field. Write down this point. Anode rays are deflecting towards external cathode in presence of external electric field. Same way, anode rays are traveling from anode to cathode, and if we kept some magnetic field, then anode rays are deflecting towards north pole. Okay, so these all things are very important, and what I was given, you write down please. This, what is this? E by m of electron. This is E by m of who? For electron. And this is what? E by m of Mr. who? E by m of Mr. Proton. This is for proton. Same you can do for neutron, no E by m value, because there is no charge for neutron. So getting everyone? So these are very important, and please have a note all these things, everyone please. Okay, so I'll go for now discovery of neutron. Discovery of neutron. Okay, discovery of neutron. Who was discovered? Who discovered neutron? Sorry. This neutron was discovered by James Chadwick. Who discovered? James Chadwick. Like I tell the kids, don't concentrate what is the spelling of James Chadwick, in which year he was discovered. That's for knowledge, not a problem actually. But here for NEET, it's unnecessary for us. Okay, simply who discovered and what he did. That's it. Because this is just information. That's it. No NEET questions, no JE questions based on this. But first I was given the three particular electron, proton, neutron, their charges as well as mass in different units. So, but you must know all those things very clearly. Getting? So very importantly, now how neutron was discovered. For many years, people thought that atom consists of only two particles. One is electron and one is proton. And proton is the heavy particle. And proton mass is how many times to the electron I was given? The mass of proton is 1837 times heavier than electron. So everybody maximum concluded that, including Rutherford, concluded that mass of atom is due to presence of protons. But this Chadwick concluded later on, no, that particular atom consists of a nucleus. That nucleus consists of two particles. One is proton and one is neutron. And the neutron is a neutral particle. Who is a neutral particle? This neutron is a neutral particle. How he observed? He also did one experiment. What is that? Beryllium sheets he was taken. Beryllium, atomic number is 4 and mass number is 9. Do you know that? Mass of electron, mass of beryllium is 9 and atomic number is 4. I was given, I think so, isotopes, isobars in previous lecture. So representation is like this. This 4 indicates atomic number of beryllium. This 4 indicates what? Atomic number of beryllium. And this 9 indicates what? Mass number. And he bombarded beryllium sheets. What is that? Bombarded means hits. Okay? Otherwise we can use other word. What is that? Through beryllium sheets, he sent alpha rays. He sent what, sir? Alpha rays. Do you know alpha rays means helium 4? Okay? 2He4. He2 plus means 2 electrons removed particles are called alpha rays. 2 electrons removed from whom? Helium. The species which are formed after removal of 2 electrons from helium are called alpha rays. Or alpha rays consist of whom? Dipositive helium ions. What this is called? Alpha rays means, you can say now, dipositive helium ions. Dipositive helium ions are called alpha rays. Okay, so he sent these alpha rays. What these are called? Alpha rays through beryllium sheets, and he observed formation of carbon. 6 is atomic number of carbon. Carbon atomic number I was given, no? Carbon atomic number is 6 and mass number is 12. And some 0 and 1. Total 4 plus 2, 6. So there is no atomic number like that. It's just no charge also. So electrons, if there, then you will have atomic number like that. Getting? So here 0 and 1 here. Why 1? See, 9 plus 4, 13. So here 12 plus 1, 13. This 0 and 1 representation only called, what this is called? Neutron. Sir, how you know, sir? Is it visible? No. From the mass of carbon he came to know with mass 1, with unit mass. Unit mass means you know how much? 1. With unit mass, some other particle was ejected. How he came to know, understood? Intelligent fellow. He got 12 here. When alpha particles are bombarded with beryllium sheets, he observed some carbon formation with a 12 mass, and remaining is 1, no, it's total 13 here, 9 plus 4. So with remaining 1, there is some other particle, okay, with 1 mass. So who is that? Neutron. How he came to know whether this is having charge or not, whether this is neutral particle or not? Same, after sending these alpha rays through beryllium, he kept what? External electric field and magnetic field, and there is no deflection, he observed. No deflection in external electric field and magnetic field. Suppose he did this in a particular one vessel or in a tube, he did. So beryllium he bombarded with helium. Helium means alpha rays, dipositive helium. Then he observed this 6C12 and 0N1 carbon formation he observed, and carbon means black, carbon black. Okay, so neutron formation also he observed. Carbon formation means remaining with one mass, some other particle was formed, was ejected. Who is that other particle? Means some external electric field he kept. Then there is no deflection, they are moving straightly. Getting? So here many attraction things are there, sir, but I am moving very straightly like this. That means what is the meaning? I don't have any attraction. So I don't have a deflection. So I am moving straightly. So these neutrons are moving straightly even you kept external electric field or magnetic field. So neutrons are neutral particles. Okay, so this is about discovery of neutron. So finally, atom consists of three subatomic particles. One is electron, one is proton, and another is neutron. So three subatomic particles we discussed. Now we have a question where those electrons, protons, neutrons are present. Where they are present. This is very important thing for us. So to explain position of electron, position of proton and position of neutron, atomic models was given. What was given? Atomic models. Right now all these things, okay? So how to write I was given, I won't repeat every time. Okay, me only feeling bored. So what is alpha rays? Do you have idea now? Alpha rays means what? Dipositive helium ion. Charge of electron, mass of electron, charge to mass ratio, everything you must know. So now atomic models. Actually atomic structure first started by Dalton actually. Mass neither be created nor be destroyed. It can convert from one form to another form. These all things in some basic concepts of chemistry we can understand, not a problem. So that's why actually Dalton said, what said, atom only the finest particle. Atom cannot be subdivided further. Yes, atom you cannot cut, but atom is not the finest particle. Atom consists of three subatomic particles. Those was given by three smart scientists. Smart means not beauty, not handsome. So they are very smart in terms of knowledge. So they said, Mr. Dalton, you said wrong. So there are three subatomic particles. One is electron, proton and neutron. Again, our first person is J.J. Thomson only. He was given J.J. Thomson's atomic model. J.J. Thomson's atomic model first. So this plum pudding or watermelon experiment we can say. So he compared, J.J. Thomson was compared atom like watermelon. Okay, so he said atom is similar to watermelon fruit. Half of the watermelon means you just cut the watermelon into two equal halves. How it appears? It appears spherical like this. And here you have a red area, correct? So here you have a red area like this. It's marker no, so I cannot draw like that. So here you have a red area like this, clearly, correct? Correct or not? So here you have electrons like this. These are called seeds, right? Same actually, correct? So here you have a black color seeds you are having. So watermelon fruit, inside you have a red color space and that you have seeds. So here also compared in the same manner, this red color area is a positive area of atom. In positive area of atom, electrons were randomly present, he said. These black color seeds I told you, these black color seeds are called electrons, he said. So electrons randomly present, he said. So what he said as a statement, as seeds embedded means inside. So as inside these seeds present in a watermelon fruit, electrons also embedded in positive area of atom. So he was unable to explain neutrality of atom. So how many electrons are present, how many protons are present, number of protons is equals to number of electrons or not, like that he was not explained. But what he said, just he was given one small information first. As seeds embedded in watermelon fruit, electrons also embedded in positive area of atom, he said. Otherwise, he compared with the plums in cake. Plums, do you know plums means some different colors, which was embedded. Embedded means which was situated inside, half outside, like that. Embedded means. Understanding? If we use some force by using some pin, what will happen? Half of the pin inside, half of the pin outside. That is called embedding. Getting what I am saying? So as plums embedded on cake, electrons also embedded on positive area of atom. But unfortunately, this is also failed. Failed in the sense he was not given the path of electron. He said electrons and protons are present like that in an atom, he said. But how much exactly this is correct means, yes, you have electrons, you have protons, up to that okay. But what about neutrons? So that was not explained. So no word at the time of J.J. Thomson atomic model. Even Rutherford also said nucleus consists of protons and around nucleus electrons are revolving in circular orbits, circular paths, which are called orbits or shells. That's why Rutherford experiment we called alpha particle scattering. That is like a planetary model. Okay, so in planetary model, what happens? Planets revolving around sun. Okay, as well as Earth revolving around sun. Remaining planets revolving around sun, like electrons are revolving around the nucleus. That said, that was given by Mr. Rutherford. But there also, Chadwick was concluded, my dear Rutherford, nucleus consists of both protons and neutrons. So in our next class, we will discuss about Rutherford experiment. So once if we complete, then we will enter into our serious topics like wave nature of electron, what is the wavelength, frequency, okay, energy of particular waves. These all things we will discuss. Planck quantum theory, okay, photoelectric effect, afterwards hydrogen spectrum, very important. But these are all just given information. We have to start from beginning, no? So that's why I was given. Okay.